Hello everyone, welcome to ROCF2 Institute, and today we will be doing chapter 1 of mathematics class 10 CBSE. So today we are dealing with real numbers of class 10 chapter 1 mathematics. So what are real numbers? The basic question that comes in the mind first, what are real numbers? How they basically originate from? You know, what do you know about real numbers? What are the basic concepts about real numbers? And if you know anything about it, then I would love if you comment down below. Now, real numbers are basically, I've said this in my class 9 videos. So suppose you have the number line. Okay, suppose you have your number line, and the number line in the middle I'm taking 0, and over here are the positive numbers. Over here are your negative numbers. Okay, so all of the numbers from 0 to the positive means all of the numbers including even 0.1, 0.001 and all of those from here also, everywhere you take all the positive numbers, any number that is positive in the whole number line, and then you take any number that is negative in the whole number line. So you take all the positive numbers, you take all the negative numbers, and then also you take 0. When you do that, the collection of all those numbers comes under the set of real number. So basically you can say the real number set has all of the positive numbers plus all of the negative numbers plus 0. So what are real numbers? 1 is a real number, 2 is a real number, 3 is a real number, -1 is a real number, -4000 is a real number. So all of the numbers in the number line are real numbers. The concept is clear? Okay. So now we'll learn about Euclid's division lemma. What is a lemma? You might ask me a question, sir, what is a lemma? We don't know anything about it. So a lemma is basically a proven statement. So it's a statement that's already been proven. A proven statement used to prove another statement. You can write this down. It is also given in your book. So it is a proven statement that has already been proved to prove another statement that has not been proved. Now let me give you an example just to give you a proper understanding of what a lemma is. Suppose gravity has already been there, means you know what is gravity, so you know how gravity works and all. So you have a statement for gravity that two masses with m1 and m2 will always attract each other. Now that statement is used to prove another statement, like how heavenly bodies move in space. So you use one proven statement to prove another statement. That is called lemma. In this chapter also, Euclid's division lemma basically means, what it says is, so leave this one aside. If you have written it, it's okay, but if you haven't written it, just leave this aside and pay attention over here. It just says that take two numbers a comma b. Okay, a comma b. Now if you divide a by b, then the resultant is the Euclid's division lemma. What it says is that a equals to bq plus r, where q is the quotient and r is the remainder. Now how it works? Suppose I give you a number like 10 and another number 5. So 10 divided by 5 will give you what? So 5 2s are 10. 5 into 2, 5 multiplied by 2 gives you 10. Now the remainder is 0 basically. Okay, so 10 when divided by 5 gives you 2. This 10 is the divisor. We call it the divisor. 2 is the quotient. 0 is the remainder, and 5 is the dividend. Okay, 5 is the dividend, 2 is the quotient, 10 is the divisor, and 0 is the remainder. Euclid's division lemma basically says that this 10 is equals to 5 into 2 plus 0. This is basically what Euclid's division lemma is. Nothing more, nothing less. So based upon this division lemma or division theorem, what you can say is that a number, a divisor, is equals to the dividend multiplied with the quotient, which leaves a remainder 0. Now, with the help of this division lemma, you can solve many different types of sum. Now here comes another term, HCF. We all know the full form of HCF. What is HCF? HCF stands for highest common factor. You can write it down. Highest common factor. HCF stands for highest common factor. Now, you can use that division lemma that you just learned right now. You can use that to find the HCF of any two numbers. How? Just pay attention. Suppose I have a number A and B. You use that division lemma, A equals to BQ plus R, to find out the HCF of A and B. How you do that? Just let me give an example. Suppose A is 120 and B is equals to 25. Okay, these are the two numbers that we have got. Okay, so apply the formula. A is equals to BQ plus R, which will give you 120 divided by 25. What will it leave? 120 divided by 25 will be 4, will give you 100, and the remainder will be 20. So you can write 120, which is A, equals to, just pay attention over here, BQ. B is our 25. 25 multiplied with Q, which is 4, gives a remainder 20. Just look at it, pay some attention, try to understand what's going on. Okay, so 120 is equals to 25 multiplied into 4, which will give you 20. Now you can also write this like this. So now take the number 25 and the quotient 20, remainder 20. Now write like this, 25 equals to, now this 20 becomes your new dividend and this 25 becomes your divisor. What you do is 25 divided by 20 and you get 1, which will give you 20, and the remainder will be 5. So do this, 20 into 1 plus 5. Continue it. You have to continue until and unless the remainder becomes 0. Continue it. So now this time 20 becomes your new dividend, 20 becomes your new divisor and 5 becomes your dividend. So do it again, 20 equals to 5 into 4 equals to 0. Plus 0, because 0 is the remainder. Now pay attention. When you continue doing this, this is first, second, third. When you continue doing this, there will be an end position where you will reach when the remainder comes to be 0. When that happens, the one which is your dividend, that is the highest common factor, HCF. So the HCF of 120 and 25 is 5, and that's the answer. If you want to rewind the video and watch it again, please do it. Watch it 3 times, 4 times, 100 times, but do understand the concept. It's very important. If you miss this concept, you will face a lot of problems in the upcoming sums. Okay, now try to understand how the highest common factor works. Okay, I have these two numbers, 120 and 25. what does it say? The highest common factor is that highest common factor, the highest number between both of them, that is common in both of them, which will be factorizing 120 and 25. What do I mean by that? So there should be a highest number, okay? So it cannot be lowest. The lowest number could be 5, or the lowest number could be 1 also. 1 can divide 120 and 25 both. But I'm not asking here for the lowest number. The question is highest common factor. What you need to look around is find out the highest common factor between both these numbers. The highest common number which can factorize both these numbers. That is what highest common factor, HCF, means. This is what you need to focus. So pay attention to whenever it says highest common factor. Even if you do not know the Euclid's division lemma, you need to pay attention and focus on what does this HCF actually means. Many people get confused. They just remember LCM, HCF, and they do not pay attention to the actual terminology of these two terms. Okay, so now let's do a sum to make you all understand what this Euclid's division lemma says. So go to exercise 1.1. Okay, let's do it together. So exercise 1.1, sum number, let's do 3. Question number 3, which says that an army contingent of 616 members is to march behind an army band of 32 members in a parade. Two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Easy. So in this question it clearly says that there are a total of 616 members and they have to march behind an army band of 32 members in a parade, and two groups are to march in the same columns. So write down the total number of total number of army contingent is 616 members and they have to march behind a band. So army band of 32 members. Okay, so army band of 32 members, there's 16, and keep that in mind. One more thing is said, two groups are to march in the same number of columns. So number of groups, number of groups is 2, and it is said march in the same number of columns. What is the maximum number of columns in which they can march? So you have to find out the highest common factor, okay, so that the maximum number of groups should be 2. So one number we have got is 616 and 32 members. Keep in mind that 616 is greater than 32. Therefore, in our Euclid's division lemma, A equals to BQ plus R, A was always the greatest number, or the greater number. So 616, because it's greater than 32, A will be 616, 32 will be B. Okay, so using Euclid's division lemma, let us find out what the answer should be. So you have to write using Euclid's division lemma. I'm writing in short, you have to write it full. Okay, so using Euclid's division lemma, 616 equals to 32 into, what will be that? Okay, 616, find it out.
32, what will it give? 616, 32, if I say 1, so 32, minus, to the minus thing, and it will give you 29, 6. Next time we do this, bear this in mind, 88 by, yes, and you get the remainder as 96, so it will be 8.
So 32 into 19 plus 8. So again do it. 32 equals to, this time 32 will be the divisor, 8 will be the dividend. So 32 equals to 8 into 4 plus 0. So now our dividend was 8 and we got the remainder 0. So therefore, in the question it was said, what is the maximum number of columns? So you have to write, therefore the maximum number of columns is 8. So maximum number of columns is 8 using Euclid's division lemma. I'm sorry if the handwriting doesn't look good or if you are unable to understand something. I've tried my best. So this is what it is. This is Euclid's division lemma. And one more thing to pay attention is, in the whole process you just have to keep one thing in mind. The next step, in the every next step you take in the Euclid's division lemma, the divisor, okay, so the dividend of the first one or second one, whatever you take it, the dividend of the first one or second one or third one, the dividend will become the divisor in the next step, and the remainder will become the dividend in the next step. You have to keep that in mind and everything else will be easy. So there was one more sum that I was very interested in. Where is the duster? Okay, so there was this sum number 5 from exercise 1.1, which seems to be really interesting, and let us do this just for the sake. Okay, so if you were wondering why am I not doing all of the sums, you can just go to the description box. A PDF file will be there for all of the sums. In the description box it's all given for free, no extra cost. Just go to in the description box and find out the PDFs for your other sums. All of the sum solutions along with some special notes are given down below, but I will suggest you download those PDFs, but please do the sum on your own. Try to complete the sums. When you face problem, look at those PDFs, otherwise just don't, please. Okay, so use Euclid's division lemma. Question number 5 says use Euclid's division lemma. If you haven't opened your book, please open your book, because I will be continuously saying the question and you won't be paying attention to it. So please open your books and go to exercise 1.1. So use Euclid's division lemma to show that the cube of any positive integer is of the form. So using Euclid's division lemma, so you have to prove what? Prove 9m comma 9m plus 1 or 9m plus 8. So using Euclid's division lemma, you have to prove that 9m, after which 9m plus 1 or 9m plus 8. So it is said that the cube of any positive integer, suppose the positive integer is 2 to the power 3. So 2 to the power 3 will be in the form either 9m or 9m plus 1 or 9m plus 8. So you have to show this. How will you do this? If you know how to do it, pause the video, try to understand the question properly, apply the Euclid's division lemma, and if you have done it, write, comment down in the comment section. I will really appreciate it. Okay. So now if you have done it, really well done, but if you haven't, pay attention. So suppose the number that we are having, so a to the power 3. A is any integer. You have to write it. A is any positive integer. Positive. A is any positive integer. Okay, done. A is any positive integer. Now, if A is any integer, just like 2, we also have to take B as 9. Now I can apply the Euclid's division lemma. A equals to B Q plus R. I can apply that. So B is 9. So I can say A cube. So A cube is the any integer. So A is any integer. I have to write according to the question. So write it down. According to question, A cube is equals to bm. A cube is equals to bm plus r. B is 9, so 9m plus r. Now one thing to keep in mind. 9 is the divisor. A cube is the 9 is the dividend and A cube is the divisor. That means A cube 9, and whatever I do, R will be the remainder. Okay, whatever I do. So in that case, you have to keep in mind that R can never be greater than 9. R can never be greater than 9. R is always greater than or equal to 0 and smaller than 9 or smaller than B in any case. So whatever the remainder will be, it can never be greater than the dividend. Keep that in mind. It will always be smaller than the dividend. It can be 0. The remainder can be 0, as you might have seen in many cases, like 10 divided by 5. The remainder is 0. But the remainder is never greater than the dividend, no matter what. Okay? So here our dividend is 9. So remainder will not be greater than the dividend itself. For I can write the possibilities of the remainder is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, done. From 0 to 8, these are the possibilities of the remainder. So if the remainder can be from 0 to 8, I can say that a to the power 3 is equals to 9m plus 1. A to the power 3 is equals to 9m plus 0, which will give me 9m, and a to the power 3 is equals to 9m plus 8. Why? Because these are all the possibilities of remainder. So if these are the possibilities, then definitely my remainder can be 1, can be 0, can be 8. And I can say, according to Euclid's division lemma, a to the power 3 is equals to 9m plus 1, 9m or 9m plus 8. And a is any positive integer. To the power 3 are these. So, proved. This was a really interesting sum. Okay, I hope you were able to do this, and if you weren't, not a big deal. You can do it. These are easy questions. You have to practice a lot more, and you have to pay attention to whatever you do in this chapter. It's a very important chapter, and it is based on the concepts that you have gained in class 9. So definitely, if you want to clear your concepts based on real numbers, integers, your number line, then class 9 videos are already there. You go and watch those videos. They will be very helpful if you want to clear your concepts. And second thing is, this chapter might look easy if you're just doing from your NCERT book, but I will suggest pick your R.D. Sharma. That is very important if you want to level up your game. NCERT book sums are kind of very easy if you practice a lot, but R.D. Sharma sums, they will open up your mind, they will open up your thought process, and that is what you need when you're practicing maths. Okay, I'm done with exercise 1.1. Next time I'll do with an exercise 1.2, and I will also discuss about the fundamental theory of arithmetic, and we'll also go towards the irrational numbers and rational numbers a little bit. Okay, so now just for fun fact and just for you all to just you get a little bit of knowledge, so let me tell you about algorithm. You might have heard about this algorithm. Okay, the Euclid's division lemma was also based on an algorithm. You might have seen that Euclid's division lemma, the division lemma, was going through step-by-step processes in which every time the dividend and the divisor was changing in a particular way. We call it a systematic way, and we also name it algorithm. What is an algorithm? An algorithm is a predefined process that you take step by step to solve a problem. Algorithm was first given by an Egyptian mathematician whose name is Muhammad ibn Musa al-Khwarizmi. If you do not understand what I'm saying, the name is just flashing right over here. So Musa or al-Khwarizmi is a very well known mathematician of his time. So he is very well known for his famous works on algebra, which he gave to all mathematicians. Subscribe the channel if you want more videos on class 10 and class 9 and CBSE and both ICSE. I'm trying